Hi everybody, this is Eduardo Suarez. If you have seen part 1 of this video, I'll show you how to configure iRVision 2D for this particular configuration where we have two robots. In this case, robot 1 is the one that has the iRVision 2D option package installed, and also is the one that has the camera connected to, and robot 2 is the one that holds the calibration grid. I show you that for this configuration, we need to set up RIP interface connection between the two robots, and also we need to have an application user frame that is common to both robots. Also show you that when we look at the program, on the vision gate offset, there is an option for selecting the robot where the offset is coming from, and you may be wondering how this option can be used, and that is exactly what we're going to do in this video. We're going to start with the same word cell, and we're going to change the name. We're going to reuse part of the word cell, but also we're going to make some changes. For this configuration, we're going to use a fixed frame offset. That means that we're going to have the part on the table, and we're going to pick it up using robot 2. Still, we're going to have the camera connected to robot 1. We're going to get the offset using the vision process that we run in robot 1. And then we're going to send the offset to robot 2 to pick up the part with the right offset. So part of the changes that we're going to do, we're going to install iRVision 2D option package on robot 2, and we're going to set up the common user frame for both robots. We're going to start verifying that the camera is connected to robot 1. We're going to select robot controller 1. We're going to go to vision. We're going to go to properties. And we're going to verify that we have the camera connected to port 1 on the robot controller 1. Now we're going to select robot controller number 2. We're going to select the robot. We're going to go to properties. We're going to select serialize robot. And on the wizard, we're going to select robot options. And we're going to install the iRVision 2D package R685. On my case, I have this one already installed. So now we're going to go to next. And we're going to select finished. And then apply. After the robot controller applied the changes, we can close this window. Now we're going to set a user frame that's common for both robots, and this is going to be the offset frame. We have already an application frame that's common for both robots, so we're going to use the application frame as an offset frame. We're going to select robot controller 1, and we're going to select the user frame number 1. You can see that we have the user frame set on the corner for the table with this orientation. And now if we select the robot controller number 2 and we go to user frame and select the user frame number 1, we have the same origin and the same orientation for the coordinates. So we need to verify that the user frame that we use as an offset frame has to have the same origin and orientation for robot 1 and robot 2, and also it has to have the same user frame number. One more thing that we're going to do, we're going to select the user tool number 1, and we're going to add a vacuum gripper, and also we're going to go to properties, we're going to go to the user tool, and we're going to set the user tool frame. One thing that we're going to do, we're going to make sure that the orientation for the Z-axis is the same orientation that we have for the calibration grid frame. We're going to go back to the robot controller 1, and this time we're going to select the user tool number 2, And on the user tool number 2, we're gonna add a pointer, and we're gonna set the user tool frame for the pointer. We're gonna use this pointer for setting up the calibration grid frame. Now we're gonna set the calibration grid on the table, and we're gonna open the teach pendant. We're gonna select the robot controller number 1. We're gonna go to menu, set up frames, and we're gonna select the user frames. And we're gonna set the user frame number 2 as the calibration grid frame. We're gonna go to details, and we're gonna use the 4-point method for setting up the calibration grid frame. So we're gonna change the coordinates. We're gonna select the user tool number 2 and the user frame number 2. We're gonna set the origin. In my case, this is already set. So we're gonna go to Shift, Move to, and once we are in the origin, we're gonna do the Shift, Record. Then we're gonna go to the X direction. Once we are on the X direction, we're gonna do the same, Shift, Record, and we're gonna proceed with the Y direction, and finally with the system origin. Once we have all the points set up, we have already the calibration grid frame set. And with this, we have all that we need for setting up the camera data and the vision process on Robot Controller 1. We're going to move the robot out of the way. We're going to go back to the teach pendant. We're going to change the coordinates. It's going to be user number 0, and the tool is going to be user tool number 1. And we're going to go back to home. Now we're going to go to robot. We're going to select Internet Explorer. We're going to select the iRVision vision setup, and we're going to create a new camera data. We're going to go to Edit. For the camera setup, we're going to select the camera. For raw mounted camera, we're going to select No. And for calibration, we're going to select the grid pattern calibration. We're going to go to the calibration setup. The robot to be observed is going to be this robot on group number 1. The application frame is going to be the user frame number 1. The grid spacing is going to be 30 millimeters. And the setting calibration grid position method is going to be use frame. We're going to select calibration grid location. The calibration grid frame is going to be user frame number 2. That's the one that was set for the calibration grid frame. And we're going to set the calibration grid position status. We're going to go to calibration. The number of planes is going to be only 1. Projection is going to be perspective. For camera distance, we're going to select override focal distance. And here we're going to select 20 millimeters. That's the lens that I'm using. And we're going to set the first plane. And finally, we're gonna go to calibration points and do the calibration result. We're gonna save and we can end the edit. We're gonna go back to the work cell and we're gonna remove the calibration grid and we're gonna put the part. Now we're gonna go back to iRVision and we're gonna create a vision process. We're gonna select the 2D single view vision process. We're gonna go to edit. On the parent tool, we're gonna select the camera. It's gonna be camera 1. Number to find is gonna be 1. Offset mode, we're gonna select the fixed frame offset. The offset frame is gonna be the user frame and it's gonna be user frame number 1. That is gonna be the application frame, but at the same time, it's gonna be the user frame. For the image lock mode, we are not gonna lock any image. And now we're gonna select the snap tool. Over here, we're not gonna make any changes. We're gonna go to the GPM locator tool number 1. We're gonna take a snapshot and we're gonna teach the part. We're gonna set the origin. And for the degree of freedom, we can select something like a minus 10 degrees to plus 10 degrees. We're gonna go to the offset data calculation tool. The reference data to be used is gonna be static. The part Z height, we need to set that. In our case, it's gonna be 50 millimeters. That's the distance that we have from the surface of the part to the calibration grid. And we're gonna set the reference position. We're gonna save, and now we can go back to the work cell. Now we're ready to start writing our TP program. We're gonna open the teach pendant. We're gonna select robot controller number 1. We're gonna press select, and we're gonna select the main program. You're gonna notice that the main program in robot number 1 is very simple. We have this first line is gonna be the initialized data. We're gonna need a handshake between the robot controller number 1 and controller number 2 to tell them each other when they are ready to do the part of the sequence. So what we're gonna do here on step number 6, we're gonna do the vision run find with the vision process. Notice that in line number 7, I remarked the vision get offset for the vision process. We are not gonna get the vision offset over here. We're gonna get the vision offset on robot controller number 2. So this line doesn't need to be executed over here. And then we're gonna have a digital output number 1 that we're gonna set to on to tell robot controller number 2 that we have already executed the vision run file, and we're going to wait for robot controller number 2 to tell us in the digital input number 1 that the handshake has been received, and then we're going to set the digital output number 1 to off, and we're going to end the cycle. Now we're going to select the robot controller number 2. We're going to go to select, and we're going to select the main program. You're going to notice in here that the main program still we have some handshake with the robot controller number 1. First, we're going to initialize the digital output number 1 to off. We're going to move to home position, and we're going to set the digital output number 1 to on, meaning that we are going to send the signal to the robot controller number 1 to run the vision process. Once we receive the digital input number 1, meaning that the robot controller 1 has executed the run vision process, we're going to execute on robot controller number 2 the vision get offset. And you're going to see here that is where we are applying the robot number 1. So in this case, we're going to select robot, we're going to select robot number 1, and we're going to go to choice, and we're going to select the vision process. And then we're going to set the vision register number 1 and the label if the vision get offset failed. The next step is going to be setting the digital output number 1 to off, meaning that we got the offset, and we are going to move to the peak position. We're going to change the user frame, and we're going to execute the move statements. We're going to go to the approach position, to the peak position, and then to the retreat position. In my case, I have already taught the peak position, and we're going to add the offset for the vision register number 1. Finally, we're going to end the program. Now we need to set up the handshake between the two robots. There are two ways we can do that. We can use a PLC to work as a middleman. The PLC is going to read the digital output from one robot and set a digital input on the other robot. The other way we can do that, we can set a digital I/O communication between the two robots. I'm not going to explain how to do this I/O communication between the two robots on the real controller. It's not part of the scope of this video. Instead, I'm going to show you how to do that on Robot Guide. We're going to select SAL. We're going to go to I/O inner connection. You're going to see that we have a pop-up window with a table. We're going to select Add. And on the first line, we are going to select the robot controller 1. We're going to set the digital output 1. And this is going to be connected to the robot controller number 2 on digital input number 1. We're going to add another line, and this time we're going to select the robot controller number 2 and the digital output number 1 for controller number 2 is going to be connected to the digital input number 1 on the robot controller number 1. We're going to apply, and we're going to press OK. We are ready now to start running the program. We're going to select the user tool number 1 on the robot controller number 2. We're going to go to properties, and we're going to make the part visible. And now we can start running the program in step mode. We're going to start running the program on the robot controller number 2. We're going to move to home. we're going to set the digital output number 1 to on, and now we're going to wait for the digital input number 1 on. So for that, we need to go back to the robot controller number 1. Now, robot controller number 1 is waiting for the digital input number 1 to be on. The digital input 1 was on, and it executed the Vision run file. So now we should be able to get the Vision offset on the robot controller number 2. We want to continue running the program, and we're going to set the digital output number 1 to on. And we're going to be waiting for the digital input number 1 to be off to set the digital output 1 off again and end the program. With this, we can go back to the robot controller number 2. We're going to set the data to Vision register, and we're going to select the Vision register number 1. Notice that this is uninitialized for the moment. We're going to continue running the program on the robot controller number 2. At this point, we're waiting for the digital input number 1 to be on. And now we're going to get the Vision offset. Because right now we have the part on the reference position, the Vision offset is 0. And we're going to set the digital output number 1 to off. Now we can move to the peak position. We're going to pick the part, and we're going to go to the retreat position, and we can go back to home. We can go back to the robot controller number 1 and finish executing the program. Notice that this is a lot of handshake between the robot controller number 1 and robot controller number 2. The next thing we're going to do, we're going to apply an offset to the part. We're going to do something like a 20 millimeters. And we can run the program again. We're going to go to home. We set the digital output on, and we're waiting for the digital input on. We're going to run the Vision process. We're going to get the Vision offset. Notice that we have the Vision offset of 20 millimeters. And we're going to go to pick up the part. Notice that they got the right offset. And we're going to finish running the program on the robot controller number 1. This time we're going to apply rotation. We're going to run the program again on the robot controller number 2. We're going to run the Vision run file. We're going to get the offset. You can see that we have orientation of 7 degrees. And we're going to go to pick up the part. You can see that again we have the right offset for picking up the part. In conclusion, the main objective of this video was to show you how to use the Vision get offset instruction, getting the offset from the Vision process that we run in Robot Controller 1, and applying this offset to Robot 2. This is possible because we have the right interface connection set up, and this interface does the internal communication between the two robots. One of the key elements of this configuration is that we are using an offset frame that is common between the two robots. In that way, it's possible to apply the offset data from robot 1 to robot 2 because there is a common reference between the two robots. I'm going to leave the link to the work cell in the description below, and thank you for watching.